I'm gonna stand up right now. Oh my gosh, that was so hard to stand up. Okay, I'm just gonna sit down. Oh, that was so easy to sit down. Hi guys, I'm messing around with gravity and mass and weight. And in science, all of those things are a big deal. So I'm gonna start by talking about gravity and specifically gravitational interactions. Say that with me. Gravitational interactions. So gravitational interactions have to do with the size of things and how much mass they have, which means how big they are, and how far apart they are from each other. So the mass of an object, and I'm just going to use this pack of sticky notes, a mass of an object is really the amount of matter that something contains, okay? The more mass something has, the greater gravity it has. So which has more gravity? Which has more gravitational force? My bottle of water, which is full of water, or this packet of stickies? Which one has more gravitational force? If you think it is the bottle of water, thumbs up. If you think that it is the stickies, thumbs down. If you have no idea what's going on, stand up. Okay, the more massive item is the water. It's bigger, so it has more gravity. All right, I also have gravity and I'm bigger than this packet of Post-its, but it's not sticking to me, is it? Where is it attracted to? Wait a minute, where is it attracted to? What's pulling it down? Gravity, right? The earth is way bigger than me. And so because the earth is bigger than me, the Post-it is more attracted to the earth than it is to me. I would look kind of silly with all those Post-its on my face, wouldn't I? All right, so let me ask you a question. Are you ready? An elephant contains more matter than a mouse. Which one has more mass? An elephant has more matter than a mouse. Which one has more mass? The elephant? The mouse? If you guessed the elephant, gold star for you. All right. Now, gravitational force increases when masses are larger. So here, this has a little bit of gravity. This has a little bit more. Mrs. Donaldson has more gravity than both of these things, and the Earth is ginormous, so it has the most gravity of the three things that I just listed, okay? So the effect of gravity on things changes when things get closer together. So when things get close together, they actually have more of a gravitational force on each other. Like, did you ever wonder why the moon goes around the Earth instead of going around the sun? The moon orbits the Earth because it's closer to Earth than it is to the sun. So the force of gravity between the Earth and the moon is tighter. It's closer, right? Okay. So really, gravity only becomes noticeable when there's a really massive object, like the moon or a planet or a star, okay? We are pulled down to Earth because of gravity, right? The gravitational force pulls on the direction towards the center of the Earth. That's why as we're traveling through space going 66,000 miles an hour, a little bit faster than that, but we're like careening through space. We're not flying all off the Earth. We're attracted to Earth because the Earth is giant and has a lot of gravity. Okay. Also, our atmosphere stays by Earth because gravity, right? All right. So if I decide I'm going to go to the moon and the moon doesn't have any water, I'm going to take this water bottle with me so that I can have water on the moon. It weighs, let's say, 1 pound on Earth. If I take it to the moon, will it still be 1 pound? It will not be 1 pound because gravity affects weight. Now, if I look at this container, it says it is 6.9 fluid ounces or 500 milliliters. So it's 500 milliliters. See there? If I take it to the moon, just like this, will it have less mass? Nope. It's still going to take up the same amount of space. It's still going to take up 500 milliliters of space. The only way I can change the mass of an object is if I dump this out, right? Or if I peel off the label, the mass will be smaller, okay? So the weight of an object only changes if the strength of gravity changes, and the mass of an object will only change if you remove something from it, right? Pretty much never. All right, so can somebody explain why you might weigh more on a planet with a larger gravitational force? I'm going to let you raise your hand. Okay, so everything has gravity. Can someone explain how mass affects the strength of gravity? Raise your hand. Right, like the bigger the object, the bigger the force of gravity, right? If your friend said that there was no gravity in space, how could you convince them that there actually is gravity in space? Well, you could definitely tell them that the objects in space are orbiting other objects in space, and the reason they do that is because of the force of gravity. What object in our solar system has the most gravitational force? Raise your hand. It's the sun. The sun is huge, right? So it has the most gravitational force, so strong that it can keep all 8 planets and our dwarf planet Pluto circling around it with its force of gravity. Right? Okay, but time out. How come the sun doesn't pull us, humans? How come the sun doesn't pull humans towards the sun? In other words, why are we attracted to the surface of the earth instead of the surface of the sun? Well, the sun is a lot farther away, right, than earth. So it matters how close you are to the source of gravity as to where the gravitational attraction and interaction occurs. All right, you guys. Today's lesson is kind of fun. You're going to see how much you weigh on the surface of every planet. Now, will you look any different? No. Will you lose any mass? No. Will you lose some weight? You bet. What? Check it out. It's pretty awesome. And if you get a chance today, please watch the last video of the first moon landing. You need to know about it. It's historical and also super cool. Have an amazing day.